Hello everyone. In this video, we'll discuss about geometric progression. What is basically geometric progression? A sequence or series of real numbers which has a common ratio is said to be geometric progression, GP. In general, a GP is expressed as AR square and so on. Let us say AR power n minus 1, or I can write here n minus 2 and then AR power n minus 1. This is our term 1. This is our term 2, term 3. So we may notice like in term 1 there is no R, means it is basically R power 0. Here it is R power 1. That is why this will be our nth term and this will be our n minus 1th term. So we may notice there is a common ratio. T2 divided by T1 is AR by A, which is R. Then if I divide term 3 by term 2, it is AR square by AR, which will also give you R. Same way, if I consider term n by term n minus 1, we get AR power n minus 1 by AR power n minus 2. A and A gets cancelled and this will be R power n minus 1. And if I take this R power n minus 2 to the numerator, the power sign will change, minus n plus 2. So ultimately that also will give you R. So we may note from 2, 1, 2 and 3, the common ratio is R. So we can say nth term of a GP is AR power n minus 1. Now let us consider the sum of first n terms of a geometric progression. We'll call that as Sn. That is what you have to add all the terms, whatever I wrote earlier, A plus AR plus AR power 2 plus and so on. Then AR power n minus 1, n minus 2 plus AR power n minus 1. Call this as equation. Let me call it as equation 4. Already I wrote up to 3. Now, let's do one thing. Multiply this fourth equation by R. So what do we get? R into Sn will be equal to, for each of these terms I have to multiply R. So what will happen is first term will become AR, next term will become AR square, third term will become AR cube plus and so on. Last but one term will become, or n minus 1th term will become AR power n minus 1 and the nth term will become AR power n. Call it as equation 5. Now, if I subtract fifth equation minus fourth equation, we will have R into Sn minus Sn is equal to AR gets cancelled. Everything will get cancelled. This is the same. This will get cancelled. This will get cancelled. Likewise, here that element will get cancelled. And then this will get cancelled with this. And the previous element will get cancelled with this. So what is left is only AR power n in equation 5. And in equation 4, A will be left. So that means I can take common Sn here. R minus 1 is A R power n minus 1. So this will give us Sn as A R to the power of n minus 1 by R minus 1. Now, same thing, if I multiply numerator and denominator by -1, what do we get? We get A minus A R power n minus 1 by minus of R minus 1. That if I take the negative sign inside, what will happen is it will become A 1 minus of R power n by 1 minus of R. So we have both these formulas applicable. Generally, we use the first one, that is Sn equal to A R power n minus 1 by R minus 1 we use when R is greater than 1. And then the other one, the second one, Sn equal to A 1 minus R power n by 1 minus R we use when R is less than 1. So in this occasion we use this, in this occasion that is general practice what we do. Then one more note we can make out. Each term, or I can say except for the first and last term of a GP, all other terms are the geometric means of its preceding and succeeding terms. So what is that? Let us write once again the terms AR square and so on. Let me write AR power n minus 3, then AR power n minus 2, AR power n minus 1. Now, let us, based on the note, whatever it is, it means T2 is the geometric mean of T1 and T3. Let us verify the right-hand side. Right-hand side is geometric mean of T1 and T3, which is square root of T1 multiplied by T3. Product of the terms, geometric means, and then taking a root of it. So that is what? Square root of A into AR square, which will be square root of A square R square, which is nothing but AR. AR is nothing but T2, which is our LHS. Same way, let us do for this, means term n minus 1 should be the geometric mean of term n minus 2 and term n. Consider again the RHS of this. So RHS is square root of term n minus 2, term n, and that is equal to n minus 2th term is A R power n minus 3, A R power n minus 1. That will give you A square R to the power of n minus 3 plus n minus 1. So if I evaluate that, I will get A, and this is 2n. If I take a square root, it will become n. And then minus 4, if I take a square root in the power, it will become 2. So that is nothing but our n minus 1th term, which is our LHS. So that is the reason here we say, except for the first and last term of a geometric progression, all other terms are the geometric means of its preceding and succeeding terms. Then next we'll see infinite geometric series. So it is what? S infinity, sum of infinite geometric series means I should add AR square plus and so on up to infinity. This can be evaluated as A by 1 minus R. This is possible only if R is lesser than 1. The sum of infinite geometric series when R is less than 1 is A divided by 1 minus of R. So in case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.